Hi, welcome back to Making a Programming Language with JavaScript. In part 2b, we're going to be coding up a syntax tree printer. And if you haven't seen the previous videos, I do recommend doing that first, otherwise this might not make much sense. And this corresponds to chapter 5 of the book Crafting Interpreters. Now, the problem we're trying to solve is how do we represent tokens in a way our program can actually interpret? And with this as a brief recap from the previous video, we don't know what order this expression should be evaluated. This is what we have, a series of tokens. And what we want is something like this, a syntax tree where the series of operations is very clear and and not unambiguous compared to this. We know that, okay, we're going to evaluate this negative with the number and then everything in the parentheses, and then at the end we multiply them. It's very clear what's happening here in the syntax tree. And the language we're making locks will have a series of rules, which is called a grammar that dictates what expressions are valid and what expressions are not valid. So this is from the previous video, and in this video we're going to be coding up these expressions in, and then we'll see what happens when we have these sorts of expressions with our syntax tree printer. Let's start coding right now. And this is where we left off from the previous video. If you want to see that again, check out the GitHub link down below in the description. Now we're going to make a new file called expression.js. What we're programming here is the expressions that correspond to the grammar for our logs language here. So I'll have this diagram here and it'll be available in the GitHub link down below. So let's get started. First off, we have our base expression class. Now it's going to have an accept method, which I will explain later. And then first class here is a binary that extends our expression, since expression is the base class. So what's happening in binary? Let's look at the rule here. Binary is a rule that says, okay, we're going to have an expression followed by an operator followed by another expression. So what is expression? Expression can be, well, see here, expression. It's one of these four. It can be a literal, unary, binary, or grouping. And each of these are expressed here. So you can see that there is a bit of a recursion that this grammar allows for. So our very first expression, we're going to call it this dot. So basically, we have a constructor that we can pass in our different parameters. The left will correspond to an expression and an operator, and then the right is another expression. And we're going to instantiate it like this. Again, I'm going to talk about the accept method later on. Next, we have grouping. So grouping is basically an expression that is enclosed between two parentheses. So in this case, we're going to only take in the expression as a parameter. Next up, we have a literal. Now, a literal can be any one of these things: a number, a string, true, false, or nil. So literal is basically just a value, and that's why our constructor will take in this dot value here. And finally, we have unary. So unary is an expression with either a minus or an exclamation mark that precedes it. It's basically saying that it's not the expression. That's basically what it means. And our unary takes in, again, the operator, which is either on the minus exclamation mark, and then this right, which is basically the expression on the right side. And this is how our grammar looks like when it's coded up. And one more line here, we're just going to export all of these so that we can use it later on. Now, what is the visitor method here? Well, actually, what is the accept method? The accept method for each one of these accepts a visitor and then returns visitor dots, and then whatever the expression is. If it's a binary class, it's going to call visit binary expression, and it's going to return this. And what this lets us do is that for this visitor class, every time we call the corresponding visit binary expression or whatever method here, we're going to return everything that is part of this class. So this will return this dot expression. Here a literal, a visit literal expression will pass in this and everything in, which is this dot value here. And we'll see how that is useful for us later on when we actually code up our AST printer. Now let's make a new file under source. We're going to call this ASTPrinter.js. Our AST printer is going to be able to print out any expression we pass in, no matter how nested, and it's going to print it out into a string format that we can understand. Okay, first we make the class, and then we're going to have a print method that we can call, and print will basically accept any expression, and then they'll call the expression dot accept, and then this. And this is what we saw earlier with our accept methods here. Example, visit binary expression. So basically that means if we have a binary expression, it's going to be this is going to be called, and it's going to return the subparenthesize, which we'll call later on with the operator lexeme, and then the left and right expressions. Same with the grouping expression. So our grouping here, you can see that it's basically a group of the expression, a little expression. So this is simple. It's really just going to call the value and make it a string, because our literal is just one of these values here, a number, string, true, false, or nil. And finally, we have the unary expression. Unary expression, here it is. It has an operator with an expression to it. And that's what we're passing in here, operator and expression. So this is basically the core function of our printer here, parenthesize. And just as a quick example of what it's doing here, example, you have this parentheses, and then you're going to have the name, and then we're going to have for each expression, it's going to have another, it's going to call expression.accept.this. So it's going to be maybe like a group, and then, or maybe like a literal 1, 2, 3, blah, blah, blah. And then we can see, this is this example of some sort of string it will return, where we can see, okay, which operations need to be applied first, and then which next. And that's what's happening here in parentheses. We're going to start off with the parentheses and then the name of whatever expression we have. And then for each series of sub-expressions, we're going to be iterating over it, and then we're going to call each one .accept this. So this is a recursive expression here. So that allows us to basically keep on calling .accept this until we run into a base expression. And our base expression is a literal expression here. And then we end it out off with a closing parentheses and returning that. Now, it may seem a bit abstract right now. So that's why I'm going to make a test case where we can see what's exactly happening here. Now, let's create a new folder. We're going to call it tests. And in here, we're going to create a new file called ASTPrinter.test.js. Right. So what we're using here is some test libraries that are part of Node 18. So that's why I have in my package.json engines Node 18. It is a bit experimental, but it allows us to quickly code up a test case without installing any external libraries. All right, our AST printer is going to be testing a example of an expression, which is in this diagram here. Our expression is, well, it's going to be a binary expression that has a left expression, operator, and a right expression. And our left expression is a unary, which has a minus token, and a literal, which is a number 1 to 3. Our operator is the multiply sign. And then our right expression is a grouping that has a literal number 45.67. Let's get started here. We're going to do all our imports. So node test is experimental with node 18, but it lets us easily easily code up a test case. So our test is going to print out a nested expression as an AST. And our expression is going to be a binary here with a unary on the left side. And the unary is going to have this minus token and a literal 1 to 3. And then the operator is going to be a token star here, which is the multiply sign. And finally, our right expression is a grouping, which has a literal number 45.67. That's our expression coded up. So this is how it looks like in the diagram, and this is how it looks like in the code. And then we're going to call our ASTPrinter, and we're going to print this expression that we just passed in here. And our results, this is what we expect here. All these parentheses here. Maybe I'll just put in one line. Okay, there we go. So our expression, we're going to expect it to print out something like this. And we're going to assert that the result is going to be as expected. All right, now I want to look over this ASTPrinter line by line and see what's actually happening here. Let's start with this line here, ASTPrinter.print, and we pass an expression. All right, so this is the print method, and the expression is this diagram here. And then it's going to call the expression.accept this. So what's happening there? So that means the binary class here, it's going to call the accept method for the binary. And let's take a look at that. So this is the binary class. The accept method is basically calling visit binary expression, passing in everything binary has. So what's visit binary expression here? Visit binary expression calls this parenthesize with the first is the operator lexeme, and then the two expressions, left and right. In this case, left is a unary, right is the grouping. So this is parenthesize, and then it's going to start off the right parentheses, the name, which is the operator. So why don't we do this line by line? Okay, so right parentheses, name is the multiply sign. What's next here? And then for each expression, so for the left expression and for the right expression, we're going to iterate that one at a time. So let's start with the left expression. It's going to call the left expression dot accept and this. And that means it's going to call visit unary expression. And what is visit unary expression? Visit unary expression is basically going to call this again, parenthesize, but with the operator, which is our lexeme, and then the right expression. All right, so we're in this parenthesize again, a new parentheses here. Okay, and it's going to call it with the name here, and the name is the minus sign here because that's our operator. And the right expression, and the right expression is a literal, so it's going to call visit literal expression, which basically returns our value in the string format. So it's going to be 1, 2, 3. And that's it for the left unary expression. So we're going to end it with closing parentheses here, which is line 32, and return that. So that's how it looks like for the left unary expression. All right, now we're going to iterate. So remember, we're popped back up into the binary for each because we just finished the left expression. And then the next one is the right expression, which is grouping. So we're going to be calling expression.acceptList, which is visit grouping expression. It's going to call this parentheses with group and then the expression of the right one. So that means we're in this parentheses again. We have a new set parentheses, which is going to start off of grouping, and then the right, and then the expression is going to be a literal 45.67. Again, visit literal expression is basically just returning this number as a string. So we got grouping 45.67, and that's it for our expressions. We're going to end the parentheses there. End it. All right, so now we pop back up into binary. We finish our right grouping. So we have no more expressions. We're going to end it here and return S. And this is what we get from our expression that we pass into ASTPrinter.print. And you can see it's the same thing here. Same thing. And this is our basically our grammar coded up as expressions that are here. So you can see that there is a comment generated by tool/generate_AST. I didn't do that in this video because it's not that interesting. If you are interested in seeing how that works, it's basically a script that generates this entire file. It'll be in the GitHub link below. All right, and that's it for coding up our AST printer. In the next video, we're going to be looking at parsing expressions. That's going to be video 3A. Thank you.